Hey, my name's Evan.
Caleb Rank.
Jared Allen.
Jacob Appenzeller. For the first part of this study, the width of the Animas River was measured and sectioned into 10 subsections so that the area could be calculated. The total area of the subsection width was found to be 114.56 square feet with a total distance of 126.55 feet, with each of the depths of the subsection shown in Figure 1. The mechanical current meter that was placed at the center of each subsection, the calculated stream flow rate was calculated to be 164.75 cubic feet per second. This is shown in Figure 2. The error associated with the graph is a propagated value using the random error of 0.25 feet with the manufactured specs of the equipment's accuracy. For the second part of this study, the location where the cross-sectional area was calculated was used as an ending point for the floating marker study. The starting point was determined to be 379.65 feet upstream from the cross-sectional starting point. The average time it took for the floating marker to make its way from the start to finish was 204.05 seconds, or 3 minutes and 24 seconds, out of 3 intervals.
This is our flotation device to measure flow. Streamflow.
A correction factor of 0.8 was used due to how rough the Animas riverbed was in this area. It was used to calculate a mean velocity of 1.49 feet per second. Using the calculated area of the subsection in relation to the mean velocity, the average stream flow was determined to be 170.5 cubic feet per second, as seen in orange in Figure 3. The error associated with the graph is a propagated value using manufactured specs of the equipment's accuracy, where the 95% certainty interval of time at n equals 3 proved to be the major factor of uncertainty. In conclusion, the subsections of the width of the river of 114.56 plus or minus 0.01 square feet was calculated using equation 1, then summed together using equation 2. Accuracy of equipment was used to calculate the uncertainties. The stream flow rate of the discharge using the mechanical current meter method was 164.8 plus or minus 0.3 cubic feet per second and was calculated using equation number 3. The stream flow's rate of discharge using the floating marker method was 170 plus or minus 18 cubic feet per second. It was calculated using equation 5. A comparison of the two streamflow rates showed that although they can be compared, since the errors of each overlap, the precision of the mechanical current meter was much better than the floating marker method, leading to the conclusion that if money isn't a factor, then the mechanical current meter would be preferred method over the floating marker method when dealing with large, deep rivers and streams. When compared to the average stream flow taken by the USGS from the week before, it was clear to say that there are too many uncertainties to prove which method was more accurate. In shallow streams, with a smaller cross-sectional area, I believe the floating marker method may prove more accurate and precise, especially if the stream is too shallow to operate the mechanical current meter. Testing the floating marker method in smaller streams could give a better understanding of whether the floating marker method would be more accurate and precise than when it is in a large river or stream.
Game and I or something.
Are we gonna like group up and be like each other?
Exactly.
Yeah, come here, Jared.
Sure.
Pretend you like each other.
Ready? 1, 2, 3.
Gemini!